How are we going, guys? Today we're going to have a look at a video that looks at volumes in a particular direction. Whether it's around the x or the y-axis, the direction that we take the slices is always perpendicular. That symbol perpendicular means at right angles. So we're going to take a slice that is right angles to the axis of rotation. So if we're going to have a look at rotating something around the x-axis, let's just take any type of curve, doesn't matter what it looks like, parallel to the x-axis. So the x-axis goes in that horizontal direction, perpendicular, which is going to be something different to what we look at in terms of parallel, but perpendicular at right angles will be in that direction. So we're going to take a strip that is perpendicular to the axis of rotation. So let's go from a domain A to B. Take a very thin strip. So that very thin strip will say a very small change in x, so delta x. And if we rotate this whole strip around, going around the axis, which is x, we're going to end up getting this particular shape right here. What will we call that shape? So if we set a very small or a very thin cylindrical shape, you would have been correct in saying that. And the dimensions for this disc or washer is going to have a radius. There's your radius, which is going to be that height. Or that height. Remember, it's very thin, so that height here will be slightly shorter than this one here. But if it's very small in terms of its delta x, we can just call it the same thing, because ultimately it's going to be a very, very thin strip. So this right here is going to be the function value. Whatever we sub in, which will be the y value, that is the radius. And that small thickness we'll call delta x. So the area of this face is pi r squared. So we've got pi multiplied by the radius squared. So pi y squared, or pi times f of x squared. The volume will be pi r squared multiplied by the height, and the height, or the thickness, is delta x. So that right here is just one disk. And ultimately, if we want to go from A up to B, we're going to take an infinite number of those, infinite number of very thin ones, and the notation for that is as delta x approaches 0, so a very thin strip, we're going to add up, so the sum of all of those disks going from A up to B of the volume, which is pi r squared h, so pi times f of x squared times delta x. And if you can recall our work from integration, another notation for this, the sum, is ultimately the integral sign. This pi comes out the front, so there's the pi, and then what we've got left is f of x squared, and then we can call that dx. About the y-axis is going to be around the vertical axis. We won't call it A and B just for the sake that we looked at A and B in the last one, so we'll go from C up to D. A very thin strip we'll call delta y in this case, because it's a very small change in the y direction. So our very small disk is going to look like this, and the radius of this is going to be, well, there's the radius right here. So it's actually the x value for that, and the x value is going to be g of y. So this is f of x, talking about the function in terms of x, but we're going in the y direction, so it's not going to be y equals something, we want x equals something, but this is going to be in terms of y. So pi r squared, which will be pi x squared, or pi times g of y, all squared. The volume is going to be pi r squared h, so pi times g of x, so g of y, all squared times dy, or delta y. Same notation, write it in terms of our integration. Alright, so now let's look at a particular question. Find the volume generated when the area of this parabola, concave down parabola, and the x-axis is rotated about the x-axis. So sketch is the first thing that we need to do. So draw yourself a concave down parabola with all the features. So the x values go from -2 up to 2, and the y value has a maximum of 4. It's going around the x-axis, so perpendicular to the x-axis is going to be in that direction right here. So our very small strip will be going in the vertical direction. So draw yourself a disc. Our dimensions in this case will be, well, the radius is y. So y is in terms of x. So there's our equation. So pi times y squared, pi times, and then whatever y is, so 4 take away x squared, square that. The volume is going to be pi y squared times dx, or delta x. This expression here has just been squared. So the volume is going from -2 up to +2. And we need to look at the symmetry of this. So we can just look at going from 0 up to 2 and doubling that because of the symmetrical property. So that's why we've got 0 up to 2 in this case. The integration is not the difficult part here. That's a very straightforward mathematics integration. So integrate that and then sub in your limits of 2 and 0. And leave your answer in terms of pi, because that's your exact answer. Just try that on the calculator just to ensure that you can get that. So step number 1 is sketch. Step number 2, draw yourself your disc. Step number 3 is get your expression for area and volume. Step number 4, rewrite it in terms of limits. Then step 5 is the integration, and then actually integrate it and evaluate it. So a few different steps, but make sure that you've got that logical step-by-step series so you can find out the volume of any shape. Alright, so this is going a little bit further to what the mathematics course looks at, and the mathematics course only has volumes around the x and the y-axis. This question here is a very similar question, same parabola, but it's not rotated around the x-axis. It says find the volume generated when the parabola and y equals 3 is rotated about the line y equals 3. So y equals 3 is a horizontal line going through the y-axis at +3. So essentially we want to get the volume, so when this region is rotated around this line. So can you imagine what that volume looks like? This is being rotated around that direction. We do need to have our x and y values for the point of intersection. So solve them simultaneously and evaluate what those points are going to be. Going perpendicular to the axis of rotation, so it's going to be vertical. So draw a thin strip in the vertical direction. Draw yourself your disc. Now this particular radius is not just going to be the x or the y value, as we've seen in the previous example. This radius is going to be that vertical distance there. So it's essentially this value take away that value of 3. Okay, so it's going to be y take away 3, which is y take away 3. So it's going to be 4 take away x squared. That's what y is. 4 take away x squared. Take away 3. So you essentially have 1 take away x squared being the radius of that disk. So the area is pi r squared, pi times the radius squared, and there's our radius now. The volume of this particular disk is pi r squared h. Remember, the height of that disk is very small, so delta x. Express our volume as a limit going from -1 up to +1, and finding the sum of all of those little disks, which can be expressed also through symmetrical properties, going from 0 up to 1 and doubling that, and then integrate this expression. So integrate it, sub in your values, and there's our exact value. Example 3, find the area of the curves y equals x squared and x equals y squared when that's rotated about the line, the y-axis. Now find its volume. So this region is rotated in that direction, about the y-axis. So imagine what that shape is going to look like. We obviously need the point of intersection, so solve those simultaneously, and you end up getting 1, 1. Now the y-axis is going to be the line of rotation, so perpendicular to the y-axis is in the horizontal direction, so we essentially have the shape, the green shape, going in that direction. So if we do rotate that, we end up getting an annulus that is created by that 3D solid, and we need to find out what the 2 radii for this shape is going to be. So the red line is going from the y-axis all the way to that particular point right here. Okay, and that point there is going to be this equation. Okay, so that red parabola has y equals x squared, but if we want the expression in terms of x, well, find the square root, we end up getting y to the power of a half to make x the subject. And the blue radius, which is going to be from the y-axis to that part there, that is going to be the blue equation. And the blue equation already has the expression as x the subject. So working at the area of this white region, the white region here is going to be the large circle, pi r squared, pi times the radius squared, take away pi r squared, which that is going to be your radius. Simplifying that slightly, you end up getting y take away y to the power of 4, and then multiplying that by the small thickness, which is the volume. So just to clarify that, delta V, small volume, because we end up having a very small change in y right here, so that's why it's a delta V. Now when we find the volume, we go from the y values of 0 to 1, so from 0 up to 1 is going to be the y values, and we're finding the sum of all of those volumes going from 0 to 1. Integrate that and sub in 0 and 1, and then express your answer in exact terms of pi. Alright, a past HSC question, 1996. We end up getting a shaded region bounded by the line x equals 1, which is that line here. Y equals 1, which is that line here. Y equals -1, which is that line here. and the curve x plus y squared equals 0. And you could say that that is x equals negative y squared, which is a concave left parabola, which is that line here. So the shaded region, which is all the area inside there, is rotated 360 degrees about the line x equals 4, which is all the way over here. And you end up getting a solid formed by that rotation. So that goes around there. Now, part A, show that the area of the annulus at height y is equal to this expression in terms of y. So as that very small change in y is rotated around, we end up getting a very similar shape to what we just saw. So we can call that R, and that one capital R. So this is going to be the little r. So going from the center of that shape to here, that's little r. And little r is just going to be all of this, which is 4, take away this, which is 1. Capital R is going to be that expression right here. So that's going to be 4 units, and then we're going to add however many units that is in terms of our equation. So it's going to be 4 take away x, because this is going to be the x value, but because it's a negative value of x, it's going to be 4 take away x, and negative x is the same as y squared. So 4 take away x is going to be the same as 4 plus y squared. So we end up having the 2 radii shown, and then our volume delta y is going to be that very small thickness. We don't need the volume because the question is saying find the area. So the area is going to be pi r squared take away pi r squared, where the 2 radii are different, little r, big R. So pi r squared take away pi r squared, and remember big R is 4 plus y squared, and little r is 3. Expand it out and simplify, and you end up getting the expression that we needed to show. Part B, find the volume. So area times a height, and that height is delta y. There's our volume going from -1 to +1. Because it is symmetrical about the x-axis, we can just look at going from 0 to 1 and doubling that. When we do that, we just integrate, sub in 0 and 1, and there's our exact answer in terms of pi. So that particular volume is the first part. There's 2 different methods to calculating volumes, and that is looking at the very small strip that is taken perpendicular to the axis of rotation, and we create a disk from that. Sometimes it's a complete disk, sometimes you've got a part in the middle missing, depends on what the equation is. Alright, I hope you enjoyed the video on that first part of volume.